Hello guys, so we are going to continue the discussion with respect to linear algebra topics. Already we have covered about vectors. We saw different operation with respect to vectors and what are the applications specifically of vectors in machine learning, deep learning or data science, right? Now it's time that we go towards this amazing topic which is called as matrices, okay? So first of all, again, we will go ahead with the definition and then we will try to understand what exactly is a matrices, okay? So a matrix is a rectangular array of numbers, symbols or expressions arranged in rows and columns, okay, in rows and columns. So when we are specifically talking about matrix or matrices, it is a rectangular array of numbers, symbols or expression arranged in rows and columns, okay. And again, my major aim will be to make you understand matrices specifically to data science related things. Why do we specifically use matrices, and what is a kind of example so that you'll be able to relate it to a data science use cases, okay. So if I probably talk about matrix, it is we usually denote it by capital letter, and let's say the capital letter is A, and if this is a matrix, we will just consider that or let me just go ahead and create a matrix. So here I will just go ahead and write A is equal to, matrix is nothing but it will be a group of vectors, okay. So I can write A11, A12 like this up to A1n, similarly A21, A22, A2n, and like this we will be going, and here I will write AM1, AM2, AMN, okay. So here A is a matrix, okay, and it has elements Aij, okay, where I denotes the row and J denotes the columns, okay. And if I just consider as a general form of matrix, this is how we specifically denote it, okay. Now this can be any numbers. It can be a numerical number, it can be a floating point number, it can be a negative numbers, okay. Now let me just talk about where do we specifically use matrices. Let's consider some of the example of matrices in data science. Matrices in data science. So the first amazing example that we specifically use in data science is for data representation. Now, what do I mean by data representation? Let's consider that I have one specific data set. Let's say this is my data set. In this, I have a feature called as math score. I have a feature like physics score, and I have another feature. Let's say over here, I will go ahead and write biology score, okay. Now, these are my features in a specific data set. Now, I will consider my first row. Let's say the first row has marks like 55, 65, 75, okay. So these are the marks of student 1. So let's say this is my first record. My second record is, let's say the math score is 65, physics score is 60, and biology score is 55. So this basically indicates the score of the second student. Third student, I can probably consider, let's say math score is 70, physics score is somewhere around 45, and biology score is somewhere around 80, okay. Now here, just by seeing this data set, we will definitely be able to understand, okay, this is the first student And remember, when I say first student, these are nothing but rows, right? When we consider this rows, we are basically considering the marks of a specific student. And these are our columns, right? So here we have provided the entire data over here. Let's say the math score, physics score, and biology score. Student by student, each and every record specifies the marks of a specific student, okay? Now, how do we use matrices in data science for data representation? So if I probably want to, let's say, train a model, and when I'm training a model, I need not worry about the specific features. These features can be anything, but the main thing that I will worry about is this numerical values, right? And everything over here is considered as a vector. So this is my one vector, this is my second vector, this is my third vector, right? And here, when we combine all these vectors, we can actually form this in the form of matrix. So now this will be displayed in this way. I can use a matrix and I can probably combine all these vectors. Okay, this will be my second row with all these marks, and this will be my third row with all these marks. Okay, so here in this matrix, our matrix shape over here is nothing but 3 cross 3. What does 3 cross 3 basically mean? We have 3 rows, which indicates the marks of 3 students, okay? And then we have 3 columns. This 3 columns specifies our 3 features, which is math score, physics score, and biology score. So this is my feature 1, feature 2, feature 3. And for representing this entire data, we use a matrix format that is called as 3 cross 3. Why? Because we have 3 rows and 3 columns. Similarly, if I probably consider in this particular scenario, how many number of rows and how many number of columns we will have? We will be having m cross n, right? M rows and n columns, because they are total n columns and they are m rows, right? So this is how we basically represent a matrix with respect to shape, okay? So the entire data representation that we have, let's say if we have some kind of data set where we may have 10,000 records, 10,000 records basically means 10,000 rows. The 10,000 rows in this particular example can be the marks of 10,000 students, right? If I probably consider column wise, this indicates the feature, okay? And this is how we basically represent the entire data in machine learning, because at the end of the day, model will not understand what is feature names over here. Model only understands number, because we will specifically doing some kind of mathematical calculation while training the model, okay? So this can be one amazing example. Let's go to the second example. Now in the second example, let's talk about images in computer vision, right? So when I talk about images in computer vision, I have already spoken about this. If I consider a 3 cross 3 grayscale image, okay? Grayscale basically means black and white image. So this image can be represented by a 3 cross 3 pixels, right? Let's say these are my 3 cross 3 pixels. So here I have 0, let's say this number is 128, this number is 255, this number is 255, 128, 0, 128, 255, and 128, okay? So this entire pixels can also be represented in the form of matrices, right? Matrices. So here we have 0, 128, 255, 255, 128, 0, 128, 255, and 128. So here also we will consider this as rows and these are columns, right? And this matrix is also a 3 cross 3 matrix, okay? So similarly, images can also be represented, and here understand 0 basically means black, okay? 255, usually 255 basically means white. So if the value is ranging between 0 to 255, then you can probably consider that if it moves towards 255, it will still become whiter and whiter. If it moves towards 0, it will become darker and darker, okay? So this is an example of how image is also represented in the form of matrix, okay? There is a very important concept specifically in machine learning that we will use, which is called as confusion matrix, okay? Confusion matrix. This matrix actually helps you to calculate the accuracy of a model. Accuracy of the model. Now, the accuracy of the model basically means what? Okay, let's say if my model is there, I've trained a model. Okay, now with respect to any input that I give, let's say there are two inputs, and if I'm getting the output, this output that is predicted by this model, it is basically called as y hat. Okay, y hat basically means predicted output. Predicted output. Now, let's say if my model is predicting some output for some kind of data, and let's say I also have the truth value of this, right? Truth value of this particular input data. Then what I can do, I can basically find out the difference between the predicted and the actual output. And we can probably create a confusion matrix, which will probably talk about the accuracy of the model, right? So confusion metrics are represented by a 4x4 matrix, which is represented by 50, 10, 5, 35. Let's say this is my confusion matrix that I'm getting, and this is a 2x2, right? 2x2 matrix itself. Now this 50 that you will be seeing, it represents something called as true positives. Okay. The 10 value that you see over here, this represents something called as false negatives. Okay. And 5 indicates false positive. And the remaining 35 indicates true negative. True negative. So if we really want to understand how many our model correctly predicted, we can take this two center values. Okay. That is 50 and 35, which is nothing but true positive plus true negative divided by true positive plus false negative plus false positive plus true negative. So once we do this calculation, we will probably get the accuracy. Okay. So confusion matrix is something where you can probably check with respect to the accuracy of the model. See, these all things will be you will be learning when you start learning about machine learning, when you get into regression and classification. My main aim is just to make you understand that how all these topics are specifically related to data science. Okay. So this was something really amazing. Now, let me talk about one more thing. Okay. So, and I hope you may be knowing about this. In neural networks, right? In neural networks, matrix operations will be specifically used. Matrix operations will be specifically used. Not only in neural network, there is also an algorithm, a machine learning algorithm, which is called as linear regression. So first of all, we will go ahead and discuss about this neural network. Let's say that a basic neural network architecture looks like this. We will be having an input layer. Let's say this input layer represents our feature 1 and feature 2. Record by record we will be passing. Let's say that we have 3 nodes in the hidden layer, and finally I have my output layer. This input will be connected to all this hidden layer. Okay. This will also be connected to the output, and this will also be connected to all the hidden layer. Okay. And this is my output. One of the basic operation in neural network is something called as forward propagation. Forward propagation. So in this forward propagation, what happens is that specific operation is done when we go from the input to the hidden layer. Okay. I will just go ahead and write the mathematical equation, but if you really want to understand well, definitely you need to learn about deep learning. Okay. And I have created an amazing course with respect to ML, DL, NLP. It is one of the most trending course in Udemy. You can check it out. Okay. So here, when we do the forward propagation, here, what exactly we are doing? Okay. We take this feature 1. Okay. Or if I want to represent this, I can represent this as x1 and x2. Let's consider this as x1 and x2. So x1 is my feature 1, x2 is my feature 2. So I may have some kind of records, right, with respect to different rows. Okay. So at a time, let's say I am passing one record. In one record, I pass x1, x2, right? Now, my first operation that we do in the forward propagation is that here, when we say this input is connected to the hidden layer, here weights are initialized like W1, W2, W3, then you have W4, W5, W6. Okay. Now see, here you have two inputs and it is connected to the hidden layer 1. This is my hidden layer 1 by 6 different weights. So if I probably see the matrix, it is nothing but 2 cross 3 matrix, right? Two inputs and total number of weights that we see from one input, I'm actually getting 3 weights. So if I do 2 cross 3, it is nothing but 6 parameters we will be able to get. And that is what we are getting: W1, W2, W3, W4, W5, W6, right? So this is the most important thing that you will be able to understand, right? So the first operation that we specifically do, we take these inputs and multiply by the weights, okay? We multiply by the weights. So here you will be able to see that if you have some basic idea of neural network, here what we do W transpose X, okay? Along with this, here we will be adding bias, B1, B2, B3, okay? And then this bias can be represented as B. Now understand, what does W transpose basically mean and what does X actually mean? If I probably consider W, it is nothing but it is a combination of W1, W2, W3, W4, W5, W6, right? And if I consider X, it is nothing but X1 and X2. So what we are specifically doing, we are multiplying this matrix with this, right? So when we do W transpose, this will be inverted and then we multiply with X, right? Similarly, when we add bias is represented by B1, B2, B3 because there are 3 bias that is getting added with respect to the node. So all these are, my main aim is just to tell you that all these are specifically matrix multiplication. So here extensively matrix operation is basically used in neural network. If I consider linear regression, okay, let's say I have a data set. The feature 1 is like number of study hours, okay, number of study hours, let's say IQ, and my third feature is what will be the score that the person will be able to bring, right? So let's say if the number of study hours is 4, if the IQ is 100, the person brings somewhere around 90 marks. If the study hour is 5, if the IQ is 90, he may bring 85 hours. So these are my data set. Now here you can see this data set is basically called as my output feature. Okay, output, or we can also say this as dependent feature. Dependent feature. Okay. And similarly, if I probably consider this and this, these are my independent feature. So what my model will do is that it will take this input feature and it will predict the score. So this kind of problem statement is called as a regression problem statement. Now, in order to solve this problem, I may use a equation which is called as y is equal to mx plus c. Okay. Now, as you know, this x is nothing but x1 and x2. This m is nothing but slope. So since I just don't have one independent feature, I have two independent features. So this equation overall will be something like m1 x1 plus m2 x2 plus coefficient c. m1 is the slope of the feature x1 or coefficient of the feature x1. m2 is basically the slope or coefficient of x2. Okay. And this is the same thing what happens over here, right? Like how we are doing W transpose X. This also can be written as M transpose X plus C. And here also you can see that this M will be nothing but it will be a coefficient of M1 comma M2. And this X is nothing but it is a coefficient of X1 comma X2. So if we probably see this overall, right? This is also kind of matrix multiplication. And this is how we go ahead and calculate our coefficients M1 and M2. Once we calculate this, we actually get our best fit line based on the number of features that we have, and we'll be able to predict our output, right? So this is really important for you all to understand. Okay. Again, you need to have a deeper knowledge in order to understand more better. You need to have good understanding of regression and all, which you should learn after probably building your basics after this, right? And as I said, I've already created an amazing course. This course is all about to focus more on your basic building blocks and how things are basically working, right? So I hope you are able to understand this. One more specific thing that we can actually use this in is NLP, right? So as I said, let's take an example with respect to NLP. I have a data set which is called as review. Let's say I have this particular data set. In this data set, I have two important features. One is review and one is my output feature, that is sentiment. Okay, let's say it is a positive or negative review. The first review that I have is that I will say the food is bad. Okay, this is my first record. And here my output will become 0 because this review is bad, right? Let's say I will go ahead and write the food is good. This is my second record. Then the output will be 1, right? Now in NLP, we can convert these words into vectors. Let's say the first sentence gets converted as 0.1, 0.2, 0.3, right? We will talk about how we can convert this text into vectors as we go ahead. The second sentence can be the food is good. Here we can go ahead and write 0.4, 0.5, 0.6. Okay. And here you will be able to see that I will be getting the value as zeros and ones, right? The output feature. Now, if I combine this together, this can be one vector. Sorry, this can be one matrix and this can be another matrix, right? And even I can consider this particular matrix and I can apply different machine learning algorithms to get trained, right? So here also we can represent this text. First of all, we initially convert this into vectors. This is just one vector, one vector. When we combine multiple vectors, it basically forms a matrices. So this was all about matrix, and I hope you are able to understand this. Again, the main aim is basically to understand the topics, build our concepts and how it is used in data science use cases. So yes, this was it from my side. I will see you all in the next video. Thank you.